Okay, continuing on with the master tool method, reference from touching one tool to the work Z0 location. That tool's physical position is loaded into work coordinates as the Z master P or Z. When it touches the zero reference surface, work coordinates reading Z 0.0000 with no length offset. Then all other tools are touched and their length difference is their offset value, but of an opposite sign value. Tool 3 needs 0.92 held back when it goes to Z0, reference surface equals to minus 0.92. These numbers become the length offset stored in tool memory during the setup. So here we can see you're going to be going shorter, you're going to be going longer. And so this is the kind of offsets that we can be thinking about. For any Z-axis move after the tool length offset has been called out of the program, the tool shorter than the master receives a positive offset to move the tool further towards the work. The tool longer than the master receives a minus offset to withhold the length difference. For any Z-axis move after the tool alignment has been called out in the program, we saw this figure before, this value assumes that control combines the offset with the Z-axis move by the rules of algebra. It's possible a control could use them differently, in which case sign would be reversed. So for a summary, master tool, the master system is simple to understand and use for 2 or 3 tools. The offset numbers represent the real difference in tools, plus or minus. The problems arise when the master tool wears and must be replaced with another of different length. The master is gone. So for adding a dummy master, they're the same system, except now the master tool is never used. It needn't even be a tool. So thus we see a concept for a dummy master. For the master position method, using this method, all tools receive a length compensating offset. There is no master. The offset distance represents how far each tool must travel from the machine home to its zero position. That position is the negative value of the distance, since all machine coordinates below M/H are negative Z. So the master position summary in industry, the master position method is far more common since it works much better for multiple tool setups and for ongoing tool replacement. Remember, the offset length comp numbers represent each tool's master home position when each is at Z0. For the turning center tool offset, after mounting lathe tools in the turret, many will have differing X and Z positions. Both must be accounted for in tool offsets. Offsets are saved to adjust both the X and Y axis travel as though they are all had equal locations. Using offsets, I can call any tool to Z 0.0 and X 3.00 diameter, for example, and it goes there regardless of the setup location. And so this is a figure from the textbook. So which method? You can use either method for setup lathe tool offset 2. For lathes, I have seen, this is the author talking about this, I have seen shops use a combination where the center cutting tools, drills, reamers, are all master tools for the X-axis, no offset in X. All non-centering cutting tools, X-axis differences are noted and stored as their X offset relative to the masters. All tools will go to X 0.0 work center lines when its offset is used. Then for Z-axis offset, tools are adjusted using master position relative to MH. All tools receive a long negative offset. There is no master Z tool. Okay, we'll pause there when we'll get into this next unit of this module.